Find the gradient of the curve, x squared plus xy plus y squared equals 3, at the point minus 1, minus 1. A curve C has these parametric equations. Find the coordinates of the point C at which the tangent is parallel to the y-axis. Find the values of t for which x and y have the same rate of change with respect to t. So I've got the question here then. Okay, let's have a little look at it, shall we? So I'm going to move part B down and just worry about part A first of all. So let's get that out of the way then. And we'll do part A first. Okay, so the gradient, let's differentiate this implicitly then. So here, run along the row, differentiate term by term. So power rule, 2x to the 1, plus, this is a product, so it's u, times the v dx, which is dy dx, plus v, times du dx, this differentiates to 1, plus, this is a function of a function, something squared, 2 comes down times something to the power 1, multiplied by the something differentiated, equals, the constant differentiates to 0. So dy dx then, let's put it inside, outside a bracket, and inside there's an x, and a 2y, and that's equal to, and let's move these two terms over the other side, so it's going to be minus both of them, isn't it? So I'll put the minus outside a bracket, 2x plus y. So they're both negative, I've put them inside a bracket and taken the minus out. So dy dx then is equal to minus 2x plus y over, move the time from times to divide, x plus 2y. Okay, and we're working out the gradient at minus 1 and minus 1. So this is minus 2 minus 1 is minus 3 over minus 1 minus 2 is minus 3. So it's equal to minus 1. So that's the gradient then. Now part B. So let's have a look at this. Okay, I'm going to move it up slightly to give myself a bit more room, just in case things get a bit long-winded. So let's have a look at B then. A curve has parametric equations here. Find the coordinates of the point on C where the tangent, so we need the tangent, don't we, is parallel to the y-axis. So we need the dy dx, and so we need dx dt and dy dt. So part 1. So here, dx dt then is going to equal, differentiate 4t, and the constant goes to nothing, dy dt, let's work out that, power rule, the 3 comes down, 3t squared, 1 less, and the t differentiates to 1, doesn't it? So dy dx then is equal to 3t squared, dy dt divided by dx dt, 3t squared plus 1 divided by 4t. Now the question says find the coordinates of the point on C where the tangent is parallel to the y-axis. So if it's parallel to the y-axis, basically we're going to need it to shoot off to infinity, aren't we? It says the y-axis is vertical. So when t equals 0, so when t tends to 0 then, dy dx tends to infinity, doesn't it? Because the top will tend to 1, bottom will tend to 0, 1 over 0 will shoot off to infinity. So, okay, now find the coordinates when t is 0 then. We'll put 0 in here, you get y is 0, and you get x is minus 1. So it's at the point y is 0, x is minus 1. I'm going to check that again. Y is 0 when t is 0, x is minus 1. Yeah, that's fine. Now part 2 then. Find the t values for which x and y have the same rate of change with respect to t. So when does dx dt equal dy dt? So let's work that out. So when does 4t equal the 3t squared plus 1? So it's a quadratic in t. So we get 3t squared minus the 4t plus the 1 equals 0. Let's factorize it, hopefully. 3t and t. It has to be 1 and 1. To get the minus, we need a minus and a minus. So that tells us then t is a third from here, and t equals 1 from here. So those are the values. And then it tells us to find the t values for which x and y have the same rate of change with respect to t. So there's the t values.